Hi, welcome to section Operators. In the previous section, we learned what impact RxJava has in reactive programming, how it implements reactive streams, and some extra entities we have available. We also learned how to deal with back pressure and how to create and observe publishers. So, what is this section about? In this section, we are going to get the most out of RxJava with operators. Operators are going to allow us to transform and operate on publishers. For that, we are going to use marble diagrams to visually understand what they are doing. Let's kick off with the first video of this section, marble diagrams. By the end of the video, you will know what operators are and what marble diagrams are for. Let's start. Creating and subscribing to an observable is simple enough and may not seem overly useful, but that is just the beginning of what is possible with RxJava. Any publisher can have its output transformed by what is called an operator, and multiple operators can be chained onto publishers. Chaining operators is an integral part of RxJava and gives you the flexibility to accomplish anything you need. Operators can be used in between the source publisher and the ultimate subscriber to manipulate immediate items. In RxJava, most operators that operate on a publisher return a publisher. That doesn't mean that the modified publisher is destroyed. What happens is that a new publisher is created with the modified information. So when we chain multiple operators, in each step we are creating a new publisher each time. In each step, the new publisher is going to take the publisher of the previous step and transform it with the new functionality. We'll see how this works with an example in the next video. RxJava comes with a huge collection of operators, and that's going to be the topic of the next two videos as well. To understand operators properly, we have to introduce marble diagrams. Marble diagrams is a way of visually representing reactive data streams. They are quite useful to visualize what is happening in each step of the process. In this example, we are using a map operator to multiply by 10 the elements that are sent by the publisher. The x-axis represents time. This is the timeline of the publisher. Time flows from left to right. Those are the items emitted by the publisher. It represents a value, a call to the subscriber on next method. This vertical line indicates that the publisher has completed successfully. If instead of the vertical line you find an X, that means the publisher finished with an error. The box indicates that a transformation is being applied to the publisher. The text inside the box shows the nature of the transformation. As I mentioned before, in this case it represents a map operator which is multiplying by 10 the elements sent by the publisher. In some other marble diagrams, you can find vertical lines that go from a higher stream to the bottom one. Those lines represent the value from a source stream causing a value on the output stream. Those lines are not visible in this example, but you can imagine them if you trace a vertical line from the element 1 to the element 10. The bottommost line always represents the output of the sequence. That's a new publisher that emits the result of the transformation. Those are all the elements involved in a marble diagram. As I said before, marble diagrams are great to visualize what operators are, a way of transforming and chaining publishers.